Around with the graphs of sines and cosines. So the question is, if I take a basic sine or cosine graph and multiply it by something, or multiply x by something, or do that and add c or add d, what's going to be the effect of all of these things? So I gave you a quick link, and this is stuff that you can do for yourself as well, just by typing it in on Desmos. When you type in letters like this, it'll ask you, do you want a slider? And the answer is yes. So I'm going to go over here to the toolbar and click Consolidate. It makes the viewing a little bit nice and crisp. And let's adjust A. And in words, can somebody tell me what adjusting A is doing to my graph? Yeah. Yep, changes the amplitude. So perfect, thank you. So A adjusts the amplitude. The amplitude is equal to the absolute value of A. So if it happens to be negative, it's not going to affect the absolute value. So the absolute value of A is just going to be your amplitude. Now let's take a look at something else. The easy one. Let's do the low-hanging fruit first. That would be D. What effect does D have on the graph? Yeah, it moves it up. Yeah, it shifts it vertically. So that's going to be your vertical shift. So shift up by D. Shifts up or down by D. Now, the next two are going to be a little bit harder to discern in increasing order of difficulty. We'll go with B next. So let's adjust B, and we're going to do that slowly. What does making B bigger do? Somebody, makes more waves, and somebody has the wording that I like. It adjusts the period. So we're getting a bigger period, or a shorter period. The period of our graph is 2 pi divided by B. And finally, C. The effect of C is kind of intertwined a little bit with B, but you can see it. If everything else is held constant and you move, how about if I choose C? If you move C, that's going to shift things horizontally, and it's called a phase shift. The amount of that phase shift is going to depend on B and C. So the way I've got it, my notation here, you're going to get a phase shift of negative C over B. That's how far it's going to shift to the right. So let's play around with a couple of these graphs and try and work our way through a few things. So let's see. We'll start with something that could model your household current. And we'll do a function like that. So let me put that up here. This is be example A. I'm just going to call it Y, even though I think in my handout I have something else. It's going to be 120 sine of 30 pi x minus pi over 3. And let's see what we can do to figure out some things about this one in terms of its amplitude, its period, its phase shift. Now D is 0, so there's not going to be any vertical shift in your graph. That's okay. It doesn't have to have a vertical shift. But let's start with the easy part first. So what's the amplitude? Yeah, that's 120. So typically the current that comes into our house is a 120 to your plugs anyways. Let's figure out the period. I don't need the absolute value there. The absolute value would just be 120. The period is going to be 2 pi divided by something. What am I going to divide by? 30 pi. Perfect, 30 pi. And I hope you simplify that. Units of pi cancels out. 2 goes into 30 once, and 2 goes into 30 15 times. So the period is 1/15. Now a little bonus here, the frequency. How often do waves pass by? Is going to be the reciprocal of the period. So that's going to equal 1 over the period. What's the reciprocal of that number? 15 over 1. We'll just call it 15 for ease. So every second, you're going to see 15 waves of this function pass by. That's what this is saying. So nice. The last part's a little bit more challenging, and that is the phase shift. So the phase shift is going to be negative c over b. Well, what's c for us in this case? C is going to be negative pi over 3. So I'm going to have a double negative that's going to cancel. Divided by b, which is 30 pi. Yep, 30 pi. Let's get rid of the double negatives. Those cancel. That leaves me with pi over 3 divided by 30 pi. Now this would probably, confuse or upset a few people because you're like, oh, well, what do I do? You got all these fractions. To make it easier on yourself, let's put this over 1. Now how does that make things a little bit clearer? Well, you've got one fraction divided by another fraction. You remember what to do when you have a fraction divided by another fraction? When you divide by a fraction, you multiply by the reciprocal. So it's going to be times 1 over 30 pi. And something nice happens here. Units of pi cancels itself out. And what you're going to be left with is 1 over 90. Yay. Nice, nice, nice. Okay. How's that one looking for starters? Doing all right with that one? All right. Let's keep going. You could be asked to kind of reverse engineer these things a little bit. So in example B says find this graph of y equals a times sine of omega x minus phi. Says write the equation of the sine function that has the following characteristics. We have an amplitude of 2, a period of 6, and a phase shift of negative 1/5. So, okay. Now, they use a negative here where I used a positive. So my phase shift is negative of theirs. That's okay. We'll make it work. So this is example B. So my goal is y equals a times sine of bx plus c. And I want amplitude of 3, a period of 6 pi, and a phase shift of negative 1/5. All right, let's see what we can do. Amplitude of 3, that's pretty easy. So let's start with that one. Amp equals 3. That means A equals what? A has to equal 3, right? Now there's actually another answer that would actually work here. What would it be? Yeah, you could use negative 3. I mean, if I don't say anything else, I mean, negative 3 would be fine there. I think in all the years I've taught this, I've only seen one student answer negative 3 there. Perhaps I'm asking for it now, but hey, they got it right. I couldn't mark it wrong. Now the period, question? Oh, you had to list both of them? Okay. Uh, I, I don't think I've ever asked a question where you need to list both of them. I think that's kind of interesting, but no, I can't envision a situation where I would ask something like that. Well, I mean, it is worth noting that A could be 3 or -3. Doesn't matter, but we'll go with the positive one. Now the period, remember the period equals 2 pi over b, but here's a little pro tip for you. If you were to solve this for b equals 2 pi divided by the period. So that's kind of a nice little shortcut for us. So it'd be 2 pi divided by 6 pi. And how does that simplify? One third, right? So 2 down, 1 to go. We've got A is 1/3. We've got, or excuse me, A is 3, B is 1/3. So the last thing to do is figure out what C is. Now our phase shift, remember our phase shift is -C over B, which for us is going to be negative of C over 1/3 equals the phase shift, which is -1/5. All right, this is a little bit messy here, so let's see here. Trying to think what would be the cleanest way to clean this up. And I guess what strikes me is that when I've got -C divided by 1/3, -1/5. I mean, part of me wants to multiply both sides by the reciprocal, which you could do. Let me show you a couple different ways to do this, because I'm not sure what you're going to like best. If you're dividing something in an equation, so C is being divided by 1/3, to get rid of that, I'll multiply by 1/3. Now let me get rid of the negatives first. I'll multiply both sides by -1. That's going to cancel out the negatives. So I get C divided by 1/3 equals 1/5. And then to finish this off, instead of dividing by 1/3, I'll multiply by 1/3. And that gives me C, because these cancel, equals 1/15. So that's one way to do this. Let's take a look at it another way, just in case that one didn't work for you. So we can do -C over 1/3 equals -1/5. Let me just take care of this part right away. I'm going to write this as -C over 1 divided by 1/3. The reason I do that is because of what we did before. When you divide by a fraction, you invert and multiply. So that's -C over 1 times 3 over 1. And now this all multiplies. I get -3 times C equals -1/5. So I got rid of the fraction on the left-hand side. That makes me feel better. Once again, I'm going to multiply both sides by the reciprocal, and the reciprocal in this case is -1/3. -1/3. On the left-hand side, everything cancels. On the right-hand side, you have a negative times a negative, which is positive. The numerators multiply and give me 1. The denominator multiplies and gives me 15. So one way or another, you should get 1/15 for your answer here for C. let's put that all together. We had A was 3, B was 1/3, C was 1/15. So your function overall should look like this. Y equals 3 sine of 1/3 x plus 1/15. Okay, and that would cause a phase shift to the left of -1/5. You've got an amplitude of 1/3 and a period of 6 pi. Beautiful. Let me go back here. Which way did you like better, the first way or the second way? Which one was easier for you to follow? I need some feedback from you. First way? First one? Okay. All right, cool. Well, whichever way it works, that's fine for you. I will do this here. This is something that you don't necessarily need to do. But if you factored out the 1/3, it would be leave behind x plus 1/5. And you can see that a -1/5 would cause that to be 0. And that's showing you your phase shift to the left of -1/5. It doesn't matter if you use my notation or the book's notation up here. Notice I used a negative, I use a positive. It'll work out the right way in the end, either way. If you did it the book's way, your value of C would have been -1/15, and then you have a double negative, which would made it positive. So. Nice. Let's move on down to example C here next. And overall, what I want to show you is kind of the goal here in this section is to be able to do something like I'm doing right here. All right, so I've got some data that I collected for the average monthly temperature in the city of Detroit, starting in January and then up through July, and then back down to January, or back down to December, and then it repeats after that. So what I'd like you to be able to do, and kind of what the subject is of your math pod, and let me see if I can't open that up. Yeah, that's this right here, is for you to find two different data sets and fit a sine function and a cosine function, one of each, to your two different data sets. So you might look at this and say, yeah, it's got kind of a nice up and down shape. And you plot the sine function and realize, oh, wait a minute. Sine function is a little bit lacking there. So the easy thing to do, first of all, is to adjust the amplitude. And the way to figure out the amplitude would be something like this. You could take the high point, which is 75.4 degrees, and the low point, which is 28.1 degrees, subtract them and divide by 2. Divided by 2 is going to give you your amplitude. So, yay. So I'll change this by changing the amplitude. Okay, that looks better, but let's shut this off. I'm still a long ways from the right graph. So the next easy thing to do then would be to shift this graph up. I need to figure out where this middle line is. So, okay, let's figure out where the middle line is. Again, I want to work with these 2 points, top and bottom. If I average these, add them up and divide by 2, I get 51.575. So let's shift this up by adding that. So I took this graph and I shifted up. Okay, at least I'm looking a little bit better now. But now I've got to match the period of this graph. Remember, the period is 2 pi divided by b. Since the period here is 12, I can take and solve for b. 2 pi divided by 12 gives me pi over 6. So that's b. Let's adjust this now to affect b. And that's looking better. In fact, there's only one thing left to do, right? And that's my phase shift. Somehow or another, I've got to be able to find a value of c that shifts my graph so that it's just right. So it just fits. Now, your data might not be a perfect sine wave, and that's okay. But what you can do then is to actually solve for C. And we'll do an example like that. But when you solve for C, you should get a perfect graph. Beautiful. So, good question. There's 12 months in a year. That's how long it takes for this graph to repeat. So if I click here, we're at 1 and 28.1. 12 units away, that should be 13. So that's the distance between 2 points that are at the identical spot on the same wave. So it's a distance of 12. I could pick these 2 points and get the same numbers. So this is a 7. What should this one be? 19, right? Because you're adding 12. Yeah. So that's where you're getting the 12 from. Now, some of you might have data that repeats itself every 365 days. That's fine. Or other things. It's just going to depend on the data that you collect. But I'll give you plenty of time to work on that, and you can check your data with me before you finish handing in the assignment. All right. I'm not going to make it due until after the first exam. So, but you should probably start collecting data sooner than later, or finding, a phenomenon that you like. The tides are good, or the phases of the moon. Cyclical data that repeats itself every so often is what I'm looking for. Okay, let's continue. This is one that's straight out of your homework. Actually, yeah, let's solve this one. Suppose that the length of time between consecutive high tides is 12 hours and 28 minutes, according to the National Atmospheric Administration. On a particular day in a city, high tide occurred at 12:28 a.m., which is 0.47 hours. And let me zoom out a little bit here. Low tide occurred at 7:07 a.m., which is 7.12 hours. Water heights are measured in the amounts above or below the mean low water. The height of the water at high tide was 5.86 feet, and at low tide, the low tide was 0.04 foot. Completes part A through C. So this is approximately when will the next high tide hit. All right. I think first things first, we got to figure out a function like this. Y equals a sine bx plus c plus d. We need something that models that data pretty carefully. So first things first, let's figure out what a is. Now to figure out what a is, we need to know the amplitude. So what information do I need to know to figure out the amplitude? Well, let's see. This is example C. Well, the amplitude is going to be half the distance of the high tide minus the low tide. So as far as the amplitude is concerned, I'm going to take 5.86 feet and 0.04 feet and do what? Well, what am I going to do with those two numbers to give me the amplitude? Excellent. Subtract and then divide by 2. I didn't see who gave it to me, but I really appreciate it. Thank you. So subtract them, divide by 2. So it's going to be 5.82 divided by 2 gives me 2.91. Beautiful. So that's my amplitude. Now I need to shift it up to that middle line. So let me just write down y equals a sine bx plus c plus d. To shift it up to the right height, I need to find the average of those two. So that's going to be 5.86 plus 0.04 divided by 2. So 5.9 divided by 2 is 2.95. Okay. Great. 2 down, 2 to go. let's work on B next. So B is going to equal 2 pi divided by the period. In words, what is the period? What's the period of that graph in words? Yeah, how often it repeats. Great. And let's see if we can't figure that out based on what it says here. So high tide occurred at, let's see here. No, even better than that. The length of time between high tides was 12 hours and 28 minutes. That's your period, right there, 12 hours and 28 minutes. There is one thing you're going to have to adjust. You know what it's going to be. You have to get rid of units of minutes. So you can take 28 minutes divided by 60 to convert it to units of hours. So everything is in units of hours. And then I can add 12, and that's my period. Call it 12.47 hours. So the period is 12.47. 12.47. If I take 2 pi and divide it by 12.47, I should get a nice decimal value for B. So I'll take 2 pi, I'll do it this way, 2 pi divided by, now I'm kind of torn here. Part of me just wants to write 12.47, that'd be easy. But there's another part of me that says, you know what, let's just go up here and I'll grab that. So you hit the up arrow key, press enter, and it copies it down there for you. So about 0.504. So I'll write that as approximately 0.504. That's B. Three down, 1 to go. All right, let's keep going. What else do we need to know here? Low tide occurred, let's see, high tide occurred at 12:28 a.m., 0.47 hours. All right, that's what I need right there. Low tide occurred, no, high tide occurred at 0.47 hours. So in order for us to get a high tide, let's put in all the information we've got. So we've got y equals 2.91 times sine of 0.504 x plus c plus 2.95. Okay. In order to get a high tide, this value has to be where sine has its maximum. What value does sine reach when it gets to its maximum in radians? Where does the sine function peak? Or you can think of it in degrees and then convert to radians. Sine is the y-coordinate on the unit circle. Where on the unit circle is the sine the biggest? Yeah, pi over 2. At pi over 2, the sine function is at its biggest. So I want to know, where does this angle equal its maximum? Where does it equal pi over 2? So, okay. Now the x value for when this happens is at 0.47 hours. So at 0.47 hours plus c, that's going to equal pi over 2. So let's just solve here. It's going to be c equals pi over 2 minus whatever this is, 0.504 times 0.47. And we'll have to get a nice decimal value for that. And let's clear up that. So pi over 2 minus 0.504 times 0.47. And there we go, about 1.334. Yay, and that's it. So overall, my function should look like this. Y equals 2.91 times sine of 0.504x plus 1.334 plus 2.95. Beautiful. Let me catch up with the chat here real quick. Sure. So, let me go back to, and I appreciate the question here. Let's see. So let's take a look at this graph, right? It doesn't match the green dots, right? So I need to shift this over to the right spot. I need to figure out what value of C is going to shift that over. So that's going to be the phase shift. Now the one thing I do know is where this maximum occurs. Now on my graph here, it occurs, this was weather data, it occurs in the 7th month, which is July. So I say, okay, I know the x coordinate where this maximum occurs, and that's going to allow me to solve for everything. So what we did with this example, or what I could do with this example, in fact, let me just show you that calculation. Let's see here. So with our weather data, we've got y equals 23.65 pi over 6x minus plus c plus 51.7. So let me show you what I'm writing. This is our weather data up to you have the phase shift. So we need to figure out what C is. So what you can do first is look at your graph and say, okay, where does the maximum value of this data occur? And that maximum value is when x equals 7. So are you with me there? Just finding the maximum where the value of x occurs, that gives you your maximum. So x equals 7, that's the maximum. Now, in order for, this should be a sine here, my bad. Y equals 23.65 sine of pi over 6 times x plus c plus 51.7. So the maximum of this function is going to be when x equals 7. Pi over 6 times 7 plus c. But I know that the sine function has its maximum when you're taking the sine of pi over 2. And we can look back real quick at the graph of a sine function to see that. Let's just shut these down. Y equals sine of x. So the biggest that a sine function gets is right there, when sine is pi over 2. So I've got those two things that I know. I know that the maximum of my data occurs when x is 7, and I know the maximum of the sine function occurs when I take the sine of pi over 2. So I want those two things to overlap. So I want to know what value of x causes this whole expression to be pi over 2. And that's how I solve. So I get, this is 7 pi over 6 plus c equals pi over 2. If I move that to the side, I get c equals pi over 2 minus 7 pi over 6. And that's how I'd solve. So if I actually take and put that number back in to my graph, let's see right here, here, I could put in pi over 2 minus 7 pi over 6, and that should give me the proper graph. It should, no, don't do that. If I turn this graph off and turn this one on, it should go, what's wrong? 7 pi over 6, pi over 2. Something's wrong. What's wrong? 3 pi over 6, 6 pi, 3, negative 4. Is it plus here? There we go. Okay. So it shifts it. It shifts it so it's perfectly aligned with my maximum here. So once again, you want to choose the value of x that makes your function a maximum, and then plug it into that expression, set it equal to pi over 2, and then solve for c. Now, what I didn't show is that you can simplify that to negative, what would it be? Negative 4 pi over 6, which simplifies again to negative 2 pi over 3. And then a double negative will become positive. So, all right. It got really uncomfortably quiet here. Who was it that asked that question? Has that helped at all? Is that Crystal? Yeah, it's going to take a little practice on that one. All right, but yeah. So pi over 2, that's what you'd use for a sine function. But where does cosine have its maximum? If I wanted to do this for a cosine function, then I'd have to use a different maximum. So if I wanted y equals 23.65 times cosine of pi over 6x plus c equal plus 51.7, if this was my model, and I said, all right, x equals 7 is my maximum, so that's going to be pi over 6 times 7 plus c. You're going to have to think a little differently. Where does the cosine function have its maximum? So, say again? Not pi. Let's take a look. Oh, 2 pi. Yeah, 2 pi would work, but you don't have to go all the way out to 2 pi. How about 0? So what you would do there is you would set it equal to 0 and find that c equals negative 7 pi over 6, and that would be where you would get your maximum for a cosine function. So I think I actually plugged that one into the graph here. Let's just take a look back. No, it didn't save it, but I should be able to graph that. So let's try it. Y equals 23.65 cosine of pi x over 6 minus 7 pi over 6 plus 51.7. Oops, that 51.7's got to be outside here. 51 plus 51.7. How about 51.7 not divided by 7? There we go. So it took a little bit, but that's your cosine function fit to the same data. So hopefully, again, that adds a little bit to help here. I do want to take a look at one of the problems that you'll do in your homework. Okay. And I think it's problem number 6, because I want to get you familiar with graphing these things on your homework, how the graph stuff works. So let's try and buzz through this one. So our function is y equals -2 sine of -6x plus pi over 2. So y equals -2 sine of -6x plus pi over 2. First things first, what's the amplitude? And that one I hope that you can read off. What's the amplitude? Perfect. So amplitude equals 2. We're good on that one. So 2 and enter. All right, good job. What's the period? Well, all right. The period equals 2 pi divided by b, which is 2 pi divided by -6. I don't think that the negative is really going to come into play here. The 2 cancels, leaves me with pi over 3. Now the cool thing about your web or your homework is that you can just type in p followed by I, and it should give you the letter pi or the number pi, pi divided by 3. All right, fantastic, we're on a roll. So the next thing is the phase shift. What's the phase shift? Well, let's practice the phase shift. Remember the phase shift, phase is -c over b, which is the negative of pi over 2 divided by -6. Now the 2 negatives cancel, so I'll get rid of those. All right, this is pi over 2 divided by 6 over 1. So just treating this as a fraction, making it a fraction so that you can invert and multiply. Pi over 6 times 1 over 6, there's no cancellation here. You're just going to get pi over 36. Oh, you know what? I'm sorry. Thank you. I changed things up here. I accidentally wrote a 6 here. So let's try that again. Pi over 2 times the reciprocal here, which is 1 over 6, which is going to be pi over 12. Thank you so much. So let's enter that one in and see if we're okay there. So yeah, so what I'm saying is that I don't think they're going to put the negative in with the period, so I just dropped it. So pi over 12. Nice work. Yeah. So yeah, that's probably more formally like this. I'll be honest with you. They caught me off guard when they gave me a negative coefficient in front of that value there. Let me show you what the negative is going to do to your graph, because that's going to play into how we graph this on my math lab. So coming back here to your sine graph, or your, well, we got a cosine here. Let me put in the sine graph. Y equals sine of x. Let's do 2x. Yeah, 2x. If I put in a negative there, sine of negative 2x, notice what happens. It reflects the graph around the x-axis or around the y-axis. You could also think of it as reflecting around the x-axis, but really this kind of substitution is reflecting it around the y-axis. It looks like both because it's an odd function, but let's finish this up here. Where's the homework? Right there. So to finish this up, we want to click on the graph and graph this. So it says click on this to enlarge this. And first thing you have to decide is, well, what kind of graph you're going to use. So I want to use this one because that's a sine graph. How come it's the sine graph? Well, it's going to start at the origin and then go up and then down. Whereas this starts away from the origin, goes down and then up. So I'll click that. And let's graph that. When you put it on your graph and click here, it gives you this little palette. Now we're going to adjust things like, first of all, we can adjust the amplitude. Let's make that 2. What else do I want to adjust? The period. I want that to be pi over 3. So let me get rid of the 2 here and adjust that to pi divided by 3. All right, that's looking better. There's no vertical shift. That would be D. So my vertical shift is going to remain 0. My phase shift is going to be pi over 12. So pi divided by 12. And what else? Well, the negative out in front of this, what's that do to your graph? It reflects it around the x-axis. So I got to check that box there. I got to reflect around the x-axis. So let me get back here. Editing tool, come on. There we go. So just click on the graph to get the editing tool. So I want to reflect it around the x-axis, and because I got a negative in front of the 6, I got to reflect it around the y-axis as well. So, all right, that's going to create a negative phase shift. I don't think I want it then. Let's see. Yeah, they put in a negative there. I didn't want that there. So let's see how we did. Check the answer. Bam. Nice work. So just wanted to give you a quick example of that. It does take a little bit of work, but it's actually better than what I used to do for people in this stuff, and that was the 5-point method. You can take a look at some of the stuff on the handouts if you really want to, if you're super bored with nothing else to do. You know, as challenging as putting in these graphs could be, you know, it's a little bit easier than some of the other things we can do. All right, I think I'm out of time here. Comments or questions before we wrap it up? All right, let me shut down this. All right, let's shut down this. Are there questions about the material or just other things? All right, let's shut this down then.